Hi there, welcome to my channel on chemistry lessons. So this is a BTEC Applied Science Unit 5 and we're going to look at displayed and structural formula in organic chemistry. In terms of the specification then, it's the fourth point down on Learning AMA 2. So if you haven't seen previous videos where we've looked at introduction to alkanes and alkenes and we've also looked at how we can use the IUPAC rules to name, then I suggest you go and watch those first. You will find a link in the description. So by the end of this video, we're going to look at how we switch between using full displayed and structural formula. First up though, if you don't subscribe, please do. Your support is very much appreciated. Use the comments and the like features and let me know what you think. So let's start off with a definition for the molecular formula, because this is something that you will have used for a couple of years now. The molecular formula just shows us the number and type of atoms. It doesn't give us any information about the structure. So the molecular formula of both of these molecules here is in fact the same. It's C5H11Br. That's just telling us that there are 5 carbon atoms, 11 hydrogen atoms and 1 bromine atom. And it doesn't show us anything about the structure. The displayed formula shows all the atoms and all the bonds. So the one on the left would be an example of a displayed formula. Now the structural formula shows us the structure of the molecule without showing the bonds. So the one on the right is in fact the structural formula of the one on the left. So what we're going to do is look at some examples now. So let's look at this displayed formula here and try and turn it into a structural formula. So we know this is a displayed formula because it's showing all the atoms and all the bonds. Now, I'm going to start with the left-hand side. The first carbon is a CH3. I'm going to start with CH3. The second carbon is a CH2. So we've done CH3, CH2. The third carbon is a little bit more complicated. It's a CH, CH3. And if we've got 2 different groups on this carbon, we tend to put one of them in brackets. Don't have to, but we tend to put one of them in brackets. So what I'm going to do is put the CH3 in brackets. So I'm going to say CH brackets CH3 close brackets. So that's my CH and my CH3. And then finally at the end, we've got another CH3 here. Next example then. So again, same idea. We've got a CH2 at the start. Then we've got a C, CH3. Then we've got a CH, CH3, so I'm going to use my brackets again. Now I could just put a 2 outside the brackets to show that there's a second CH3 group there. So I can do this, or there's nothing wrong with me just doing another CH3 group. Both are correct. I'm going to suggest you pause the video this time and you try and do these 2 yourself, and then when you're ready to see the answer, just unpause and we'll go through them. First one then, CH3 at the beginning. Then we've got a CH, CH3, and I'm going to use brackets. And I've got the exact same thing here. I've got a CH, CH3. And then I've got a CH3 at the end. So again, I can put that 2 there, or I can opt not to put the 2 and just put another CH3 group. Second one, CH3 at the start, then CH2, then CH2, then CH, CH3, then CH2, CH3. Next couple then, slightly more complicated because this time we're looking at haloalkanes, but it's the exact same rules that you're going to apply. So I suggest you pause the video, have a go at them, and then when you're ready to see the answers, unpause. So the top one then, CH3, CBr, brackets CH3, and then another CH3 at the end. Second one, I've got C, H, Br, CH3. Then CH2, CH with a CH3 group, CH2, CH2F. Okay, so this time we're going to practice going from a structural formula to a displayed formula. So this time I need to try and draw out the full molecule from this structural formula. So the first carbon has two H's on it and a Br. So CH2Br. Then it's a CH2. Then it's a CHF, CH3. But I've made a mistake there actually, because if I'm going to do a displayed formula I have to show all the bonds. My bad, people. So CH3. You must draw all of the bonds. Now if you're getting a little panicky and thinking, well, how does he know to put the F down the bottom and the H up the top? The answer is it doesn't matter. I could put the F up the top and the H down the bottom. It makes no difference whatsoever. They are both correct. And the same rule would apply over here. How did I know to put the BR on the left? Well, again, it didn't matter. I could have put the BR where I put it. I could have put it up the top, and in which case the other two positions would have been hydrogen. Or I could have put the BR down the bottom. It really does not matter, as long as it's on that carbon. That's the important thing, that it's on the correct carbon. So next one then, let's see if we can come up with the displayed formula for this one. So the first carbon is a CH2 to a CH to a CH2 to a CH3. Now, all of my experience is telling me that this looks a little funny. And the reason I'm saying that is, perhaps I should have mentioned earlier, but from the earlier videos, carbon has to have 4 bonds. It always has 4 bonds in organic chemistry. Okay, so it has to have 4 bonds. And something's not right at the beginning because these two carbons only have 3 bonds. So we then need to be aware that this bond must be a double bond. So that is in fact an alkene. So alkenes can be awkward to spot from a structural formula. They're very obvious to spot from a displayed formula, but quite difficult to spot from a structural, which is why in some textbooks you'll actually see this drawn as this. CH2, double bond CH, CH2, CH3. So it's actually common to show a double bond in a structural formula just to help people spot, but we don't have to. So I'm going to suggest you pause the video here and you have a go at drawing the displayed formula for these 3 structural formula, and when you're ready to see the answers, unpause the video. So we've got a CH3 group at the beginning, then we've got a CH2 group, and then we've got a C with a BR and a H. Again, it doesn't matter, I put the BR at the top or the bottom, and then at the end we've got a CH3 group. Next, I've got a CH BR to a C to a BR to a CH3. Now again, my chemistry senses are tingling here, and I can see that there's something's not quite right, and that's because I need a double bond here. So well done if you've spotted that. So if you didn't spot it, perhaps you need to add into your rules that you need to start counting the bonds to make sure carbon always has 4. And the one at the bottom, I've got a CH3 group at the start, then I've got a CH with a CH3, and then I've got a CH with a CH3, again top or bottom doesn't matter, and then I've got a CH with an F to a CH3. And that brings this video to a close. The next video is going to look at skeletal formula. So check out the link in the description below for the next one, and thanks for watching.